Hey everybody, so today we're going to talk about complex numbers. Okay. So the first thing we're going to do is define the first complex number. Okay, so we're defining this new number I so that then I squared is -1. Okay, so we know that this isn't true about any of our existing real numbers, right? Any real number squared is a positive. Okay, so we're going to come up with this new number that has the property that when you square it, you get a negative number. Okay, so multiples of this number have a special name. Okay, so any multiple of I is called an imaginary number. Okay, so for example, we might have like 2i, okay, we might have -1/5 I, okay, we might have something like √2 times I, okay, these are all examples of imaginary numbers, okay. Now, what is a complex number? If this is an imaginary number, what's a complex number? Okay. Okay, so a complex number is something of this form, okay? A plus bi, where a and b are real numbers, okay? So for example, we might have something like 2 plus 3i, okay? We might have something like 1/2 minus 1/5 I, okay? We might have something like √2 plus I, okay? These are all examples of complex numbers, okay? But we can also have slightly different examples, something that looks like just 2i, which we know is an imaginary number, is also a complex number, okay? Even something as simple as 5 is a complex number, okay? All right, so let's look at the two parts, okay? Okay, so we're going to look at a complex number a plus bi, okay? So a is called the real part, okay? And bi is the imaginary part. Okay, so the two parts of complex numbers are the real part and the imaginary part. Okay, so let's look at our examples and just quickly say what the real and imaginary parts are. Okay, so we're going to have the complex number. Okay, then we're going to have its real part. Okay, and then we'll have the imaginary part. Okay, and we're just going to look at each of the examples that we listed as a complex number. So we had 2 plus 3i. we had 1/2 minus 1/5 I. Okay, we had root 2 plus I. Okay, and then we also had 2I. Okay, and we had 5. Okay, so when we look at this really typical example of a complex number here, okay, we're going to say that the real part is this part that's a real number, and the imaginary part is the imaginary number. Okay, that will work the same for this one. Our real part is 1/2, our imaginary part is negative 1/5 I. Okay, and here, the real part is root 2, and the imaginary part is just I. Okay, so these typical examples, you can see that you just list the real number part or the imaginary number part. Okay, now here, when we look at our example 2I, this doesn't have a real number part. So the real part is 0. Okay, and our imaginary part is 2I. Okay, so for 5, we only have a real number part. So our real part is 5, and our imaginary part of this number is 0. Okay? All right, so this was mainly for these two more unusual examples, but you can see how you can categorize the different parts here. Okay, let's talk about operations. Okay, so first we're going to talk about adding and subtracting complex numbers. So when we do that, okay, we are just going to combine like terms. Okay, so we're familiar with this concept of combining like terms, so let's look at an example. Okay, so here I'm going to combine my like terms. Okay, so my real parts are 11 and negative 2, so those will combine to 9. Okay, and then my imaginary part is negative 4I and negative 8I, so those will combine to negative 12I. Okay, so you combine the real number part and you combine the imaginary part. Okay, all right. Let's look at an example of subtraction. Oops. Okay, so the only difference here is that I am first going to distribute this negative sign so that I don't make an easy mistake and get my negative sign wrong. Okay, so I'm going to write this as 2 plus I minus 3 minus 7I. Okay, and then I'm going to combine my like terms. So I'll combine my real parts into negative 1. Okay, and then I'll combine the two imaginary parts. 1 minus 7 is negative 6I. Okay, so that's how you do adding and subtracting. Okay, combine like terms, and my tip for subtracting is to distribute the negative so that you don't make a negative sign mistake. Okay, all right, let's look at multiplying. Okay, so basically the key to multiplying is to distribute and combine like terms. Okay, so let's look at an example of that. Okay, so I'm going to distribute this the way that you normally distribute into parentheses. So I have 2i times 3, which is 6i. Okay, and then I have 2i times I, which is 2i squared. Okay, now at this point, I know what I squared is, right? This is part of the definition of the number I, right? I squared is -1. Okay, so I'm going to write this in the a plus bi format. Okay, and it's really important for our online homework and for the test that you're formatting all of your complex answers in this a plus bi format, right? Real part first, imaginary part second. Okay, all right. Let's look at another example of multiplying. Okay, so we're still going to distribute. So I'll do 4 times -2 is -8. 4 times 3i is 12i. Okay, -I times -2 is +2i. Okay, and -I times 3i is -3i squared. Okay, and just like the previous example, I'm going to replace I squared with -1. Okay, and now I'm going to combine all of my like terms. So -8 plus 3 is -5. 12i plus 2i is 14i. Okay, and you can see that I have that nice a plus bi format where I have this real part first and my imaginary part second. Okay, let's do one more example of this. Okay, so I'm going to start the same way by distributing. Okay, so 5 times 5 is 25. 5 times 2i is 10i. -2i times 5 is -10i. Okay, and -2i times 2i is -4i squared. Okay, now I'm going to replace I squared with -1. Okay, and I'm going to combine my like terms. 25 plus 4 is 29. Okay, -10i or +10i minus 10i is 0. Okay, so you can see when you multiply these two numbers together, right, you end up with a real number answer, right? The imaginary part cancels out and you end up with just a real number. Okay, so let's look at when that's going to happen. Okay, so this setup is actually called a complex conjugate. Okay, so we just saw an example of complex conjugates in the previous example. So we had 5 plus 2i and 5 minus 2i. So this is a perfect example of complex conjugates. Okay, you could also have something like 1/2 minus I. Okay, and its complex conjugate would be 1/2 plus I. Okay, so the real part is the same. The imaginary part has a different sign. Okay, so you can see the real part's exactly the same. The imaginary part is opposite in terms of sign. Okay, so if we have something that's just an imaginary part, like this, then its complex conjugate would be the imaginary part, right? Real parts are both 0. Imaginary parts have opposite signs. Okay, all right. So what we just saw in the previous example is something that's an example of a larger fact. Okay, so a complex number multiplied by its complex conjugate okay, will give a real number answer. Okay, so we saw that in the previous example, and that will always be true. When you have a number and you multiply it by its complex conjugate, you will get a real number value as your answer. Okay, so we're actually going to use this information to look at our next operation, which is division. Okay, so the steps here are we're going to find the complex conjugate of the denominator specifically. Okay, then we are going to multiply by this okay, so you find the complex conjugate of the denominator, and then you multiply both the numerator and the denominator by that complex conjugate. Okay, and then you're going to simplify. Okay, just like we saw with the multiplication before, there's going to be some simplifying. Okay, and then the very last step is to write your answer in the a plus bi form. Okay, and we're going to remember that we're always writing our complex numbers in this form. Okay, let's see an example of how to do this. Okay, so we're going to divide. Okay. Okay. So the first thing we're going to do is find our complex conjugate of the denominator. Okay, so since this is an imaginary number and it has a real part of 0, our complex conjugate is just going to be minus 3i. Okay, and we're going to multiply by this on the top and the bottom. Okay, so here in the denominator, okay, I'm going to get 3i times negative 3i, which is negative 9i squared. Okay, and in the top, I'm going to do 3 times 81. Okay. Okay, I. Okay, and then 3 times 9, which is 27i squared. Okay, so now we're going to simplify, and the first step we're going to take is we're going to replace both of our I squareds by negative 1. Okay. Okay, so I'm just going to rewrite this with all my numbers looking reasonable. So 243i minus 27 over 9. Okay, and now I'm going to write this, I'm going to simplify this, right? First by doing 243 divided by 9. Okay, and then I'm going to do 27 divided by 9. Okay. Okay, so this is giving me 243 divided by 9 is 27i. Okay, and then 27 divided by 9 is 3. Okay, and I remember that I'm going to write this in the a plus bi format. Okay. All right. Let's look at another example of this. Okay. So the first thing I'm going to do is find the complex conjugate for this denominator. Okay. So it's going to be real part is the same, imaginary part is the opposite. Okay, and now I'm going to multiply this out. So 2 times 2 is 4. Okay, 2 times negative I is negative 2i. I times 2 is 2i. I times negative I is negative I squared. Okay, then I'm going to do the top. 10 times 2 is 20. 10 times negative I is negative 10i. 15i times 2 is 30i. Okay, and then 15i times negative I is negative 15i squared. Okay, so just like before, we're going to replace all of our I squareds with negative 1. Okay. Okay, and now I'm going to combine my like terms. So I have 20 plus 15 is 35. Okay, now I have negative 10 plus 30 is 20i. Okay, and in the denominator, I have 4 plus 1, which is 5. Okay, and negative 2i plus positive 2i is 0. Okay, so again, because we're using the complex conjugate, our denominator is going to become a real number. And now we can split this up. 35 divided by 5 is 7. 20 divided by 5 is 4i. Okay. All right, let's do one last example of this. Okay. So the first thing we're going to do is find that complex conjugate. So the real number part is the same, and the imaginary part is the opposite. Okay, now I'm going to multiply it out. Okay, 1 times 2 is 2. 1 times 5i is 5i. 5i times 2 is 10i. Okay, and 5i times 5i is plus 25i squared. Okay. Then in the denominator, 2 times 2 is 4. This is going to give me plus 10i minus 10i minus 25i squared. Okay, and again, I'm going to replace my I squareds by negative 1. Okay, and I'm going to combine my like terms. Okay, so 2 minus 25 is negative 23. Okay, 5i plus 10i is 15i. Okay, and then let's look at our denominator. 4 plus 25 is 29. Okay, and the imaginary parts will cancel like you want them to. Okay, so again, we're going to split this up, but this time it doesn't divide evenly. Okay, so we're still splitting it up to divide here and divide here. Okay, and we're just going to leave our answer in fraction form. Okay, it's important to write it like this versus like this because this is our a plus bi format. Okay, so make sure your answer is looking like this. Okay, all right, let's look at our last example of complex numbers, which kind of hints at how we're going to see them used later on. Okay. Okay. So if we have something like square root of 16, right, this is going to be root 16 times root negative 1. Okay, square root of 16 is 4. Okay, the square root of negative 1, think if I squared is negative 1, then the square root of negative 1 should be I. Okay, so this is how we would rewrite this root with a negative number as a complex number. Okay, let's see another example of this. Okay, now we already have this 1 plus. Okay, now we know that the negative part of this is going to give us root negative 1, which is I. Okay, now we can't simplify root 5, so we're just going to leave this as root 5. Okay, and the square root of negative 1 part is going to become I. Okay, all right, let's look at one last example of this. Okay, so the first thing, oops, there we go, got ahead of myself. Okay, so the first thing we're going to do here is say that the square root of negative 2 is the same as root 2 times I. Okay, and then we're going to split this up. So we'll have 3 over 4, okay, plus 6 root 2 over 4. Okay, and we're going to cancel the common factors here. Okay, so 3 root 2 over 2 times I. Okay. All right. I hope this was a good introduction to complex numbers, and I will see you guys soon.